I'm very honored to welcome as a first speaker, Amaury Frankl from Ghent University, Department of Geography. As I have understood it, there are many co-authors involved, but Amaury will be presenting, and the title of his presentation is Building Land Resilience in Northwest Ethiopia, Lessons Learned from 5 Years of Overseas Research Collaboration, which is of course reflecting the many parties, I think. So you're welcome to share your screen. I see already your screen. Yeah, I think it's perfect now. So the floor is yours, Amaury.
Okay, thank you very much. Yes, a lot of co-authors, and basically that's the entire team. So I've been coordinating, let's say, a research project of over the past 5 years in northern Ethiopia. I'm going to present some of the results and the collaboration to all of you. So first of all, yes, it always starts 5 years ago in building a project and a team. And yes, like often, it all starts with a lot of discussion, talking, field excursions, receptions, and so on, where we share minds and ideas and start to build a project. And I was very lucky to run the team with Dr. Alemayu Wassi, who you can see on the bottom right-hand side of the screen. Oops, sorry, this is too fast. Yes. And in these first, I would say, weeks and months, it's thinking big, of course. You must remember, you must recognize these type of slides where you use Post-its to create a project, to discuss ideas, to make a list of stakeholders. And then, yes, after a while, the land resilience team was created, where we had the objective to understand patterns and processes of ecosystem degradation and propose mitigation strategies, with two main areas of interest, of focus. One, cascades of sediment, carbon, and nutrients from source to sink. And the second, the ecological effects on forest remnants and their bird communities. It's all being done in the Lake Tana Basin. That's a development corridor in northern Ethiopia. You can see in the bottom right corner, you see a map of the Horn of Africa, a Google Earth image, basically. And there you can see Lake Tana as a real landmark. And you see a bit the type of environmental problems we deal with, erosion, sediment export to the lake, and also quite some pressure on natural resources from agriculture. And if you put this in a global context, you can also see from the top figure the depths on the global tree cover. So basically, that's somehow what would be naturally available or possibly grow as forest, as compared to what still remains, as we call it, these tree cover depth. And in the bottom, the global soil erosion depth. You can also see that the Lake Tana Basin is basically a hotspot of soil erosion, because the natural, I would say, acceptable erosion is much lower than what is occurring. Second part, yes, we're standing on the shoulder of students. And that's very nice with these projects, is that we have quite some PhD students, but also master students, and they collect an impressive amount of data. And in very different fields, I would say, which are very complementary. And that's a very nice thing, that all these persons work on more or less similar topics. So we see the measurement of floodplain sediment storage. We see augering here. We see the measurement of tree diameter, breast height, sieving of sediments, measuring runoff in small catchment, agricultural catchment, from, I would say, self-made V-notches, and also the collection of bed load sediment samples. But in total, this is really an impressive data set. What do we learn from this, from all these studies? Well, this only one of the PhD students has finished already, so this is just partial information. But we see that the soil erosion rate is very high, 32 ton per hectare per hectares per year. That's quite a lot, and even 23% of the catchment, it goes beyond 50. So the land use is largely unsustainable, and in the bottom left figure you can see different types of land uses, and basically all the measurements that plots above the dotted horizontal line are unsustainable, are unacceptable. So it goes really, it's really bad in terms of erosion. Next, yeah, it's a bit slow. Strange. Okay, how was it in the past? Is it a new thing, or is it something that's already ongoing for a long time? Well, a picture tells more than 1,000 words. Here an image of 1936. You can see the river, and you can see how it is nowadays. So you see an extreme change. And we looked at these aerial photographs of all times a bit more in detail. And you can see that throughout, I would say, the past several decades, on average, vegetation cover has decreased. There was also much more variability between sites, I would say, in the past, in the 1930s and 1950s, than there is nowadays, with a much more homogeneous landscape. And as a response, we see a quite dramatic increase in gully erosion. That's an erosion feature that you can easily recognize on images. We have a doubling in gully densities in valley floor positions. Also, the trees and the ecosystem services they deliver. We have less trees, less forest. These are often small patches of forest around around churches, but also there we can see that even though these are very rich in terms of species diversity, 20% of these forests, they house 273 species of the Horn of Africa, so that's quite impressive. But we see that quite a number of these forests and a number of species in these forests are close to extinction. So the extinction depth is quite high for quite a number of species. We have very few seedlings, meaning that there is no regeneration. If you also look on the right side of the slide, you see the ecosystem supply. There also the supply, that means, I would say, climate regulation, nitrogen fixation for agricultural lands, water purification, wood for fencing, charcoal. So all these systems, I would say, quite limited in terms of how they are distributed, focused on a few areas. You have two major hotspots, at least, where we have quite good services provided by the forest, but most of these forests and also the surrounding agricultural landscape are quite poor in delivering ecosystem services. What happens then to the lake? Well, the lake receives a lot of sediments from the upper catchments. We see two major rivers producing sediment, the Gumara River and the Giggle-Abai River. So these are the biggest contributors of sediment. And if we see that about 30,000 tons of sediment enters the lake every year, in less than 1,000 years, it's full of sediment. So this is quite impressive if you imagine. On the other hand, it's quite a shallow lake as well. So it's only a few meters deep, I would say about 9-10 meters deep. So it's large, but it's also very shallow. We also looked in the sediment storage, or at least we are investigating it. We can see that still quite some sediment is stored in river floodplains. And it's also there you can see that you have some hotspots. Most often these sediment plains are low energy floodplains. And then I would say, understanding all these, I would say, patterns of land degradations, which are quite severe, we're also formulating scenarios to improve land management. And here you can see, based on the modeling exercise in the Lake Tana Basin, different scenarios and combination of land uses like agroforestry, construction of stone bins or grass strips, which would improve I would say soil conservation strategies in the catchment. We have shared results, and that's very important, of course, through a number of academic articles, so papers. but also at conferences, even on television. And our local, I would say, team leader, Alemayo, even went into prestigious, I would say, magazines and journals like Nature and National Geographic. That was quite nice. So the third and last part, the rewards, challenges, and way forward. Well, the rewards, of course, are the sharing of knowledge and expertise, building laboratories. You can see in the left picture how we are making drones together. Of course, catchment conservation and improvement of land measurement, the interaction with local communities, and of course, PhD defenses. That's a very important thing for the students. What are our challenges? Well, as I saw it, it was, I would say first, the biggest challenge was communication. It's not always easy. We see this already now with the global pandemic. Everything is online, so it's not easy to talk to each other, even at this conference. But also, I mean, from Belgium to Ethiopia, that's not always easy to organize. Managing a laboratory locally, it's also quite a challenging thing. Often you want to export expertise from the Belgium lab to the Ethiopian lab, and that's not always easy to manage because it requires quite some procedures and protocols to honor. Creating a shared and open data sets, that's still a major challenge, and then reaching out to the stakeholders, the pandemic, and also, of course, the war that's ongoing in Ethiopia. The way forward, well, I think it's important to create a collaborative culture from the beginning and really to think about these elements of how to improve communication, how to improve interaction within the project, but also with other projects, and to define clear roles and responsibilities. These things are often forgotten, as I experienced it in the beginning of the project formulation, but are very important towards the end of it. And of course, improve the impact on local communities. We take a lot of information from these communities, even if there are only soil and sediment samples or tree samples, but still we would want to have an immediate return and to make this more tangible. And then, of course, strengthen interactions with stakeholders and also other Belgian development actors. So I thank you very much. I think, Luce, I'm well in time, so 12 minutes, so leaving 3 minutes for questions, if there are any.
Yes, you've done an awesome job. I haven't seen any questions in this chat until now. Oh, but there is one now. So I'll be reading it. How can you evaluate Ethiopian tree planting in billions per year to mitigate or save the environment? Which was launched in the country by PM Abiy Ahmed. I don't really understand that last sentence, but so the first sentence, so the first question was how you would evaluate Ethiopian tree planting.
Well, yes, you have this. It's basically the Great Green Wall. Is protecting the Sahel against desertification. That's more or less in this picture, in this idea that you have to frame this question. Mm-hmm. Well, I think what we have seen from many projects, it's not the number of trees you plant that count, it's the number of trees that survive after a few years. And especially, it's all about the management of these trees. I would say it's maybe better to start protecting the very valuable forest that they already have in the study area that we worked on, and starting to improve the connectivity between these forests. That's, I think, more valuable than just planting trees randomly, if that's what they would do, of course. Yes.
Okay, I have another question. How did you take your results of your research to the local farmers? I guess they don't read NG, so the reports probably. So how does it come to them?
Yeah, well, we have in the research group quite a, I would say, tradition of having, I would say, spin-off development projects, and then also having translated, I would say, research findings to the communities, or at least presentation and I would say farmers' days and so on. But here so far, I'm afraid that, well, the combination of the pandemic 2 years ago and the war started 1 year ago, yeah, just didn't allow these things yet so far. I mean, the areas is inaccessible to us. I mean, people don't go, at least they don't really go to the field to interact with local communities for now. All the students are also, or most of them are in Belgium finishing their PhD. So yeah, this is probably a very weak deliverable of the project, given these circumstances.
Okay, I see a lot of questions, but I actually think that I will be quite strict with the timekeeper because we have many presentations and we want to allow everyone to have equal time to present, of course. So I think we need to go to the next presentation, but Joost, you can, of course, informally meet up with Amaury in a later stage, in a coffee break room. So Amaury, thank you very much.
Hello.
Hello, welcome. You're from the Department of Geography at Ghent University, and we stay again in Ethiopia. And your presentation, which you can share if you would like to, is entitled "How Changes to Land Cover and Hydrological Connectivity Between 1935 and 2020 Affect Runoff Response in the Tsili Catchment in Ethiopia." So the floor is yours. I hope we can come back later to Emnet when he has reconnected.
Okay. Can you see my screen?
Yeah, we can see it. Thank you for this.
And now still in presentation mode?
You're in presentation mode.
Yeah. Okay. Hello everyone. My name is Kiara, and today I will talk about part of my research I did in my master dissertation about changes in land cover, hydrological connectivity in a catchment in Ethiopia, and how these changes will affect the runoff response, and this over a period of 85 years. So the research questions that I will discuss with you today are what are the land cover changes that have happened over the period 1935 and 2020 in this catchment? Also, what are the changes in the drainage network and the riverbank width? And then what are now the consequences of the changes in land cover for the runoff response and hydrological connectivity in this catchment? So first of all, the study area is located in Tigray in northern Ethiopia. And as you can see at the map to the right, in the southeast corner of the catchment, we have a plateau. And northwest of the catchment, there are paddy plains. And these are separated by a very steep escarpment, just to give you an idea of what the catchment is like. To cover to map the land cover, I worked in 4 time steps. The first in 1935, then in 1967, 1994, and 2020. And for the first 3 time steps, I worked with aerial images that, of course, first had to be georeferenced before mapping. And for 2020, I used Google Earth images. For the classification, of course, because some of these aerial images have a resolution that was quite low, it was impossible to make a distinction between vegetation types or even crop types. So I just classified everything as cropland, forest, shrubland, grassland, or village area. Now on this slide, we can see the first results for 1935 and 1967. You can also see on these maps that there has been made a subdivision of the catchment in different sub-catchments. This was necessary for further modeling and looking for the consequences of these impacts on the hydrological processes. So as you can see on the map for 1935, this catchment was really dominated by shrubland, mostly along the escarpment and downslope of the escarpment. But we did see already a bit of cropland in subcatchment 1 and in subcatchment 2, a small part. There is also, let me find a pointer. There was also along the escarpment a really great forest. And also there was a lot of grassland, but this was very distributed along the catchment. And there were 3 villages already present in 1935. Now, as we move to the next map, you can see that the agriculture has really started to expand, especially in subcatchment 2. We also see a small expansion of grassland, also very distributed in the catchment, and there is also a fragmentation of the forest along the escarpment. Now, as we go to the next time step in 1994, we see that grassland is now becoming very dominant, especially along the escarpment. We also see that the forest has completely disappeared along the escarpment, but is still remaining at some parts, but in a very small extent. The agriculture is now also expanding towards the escarpment, but also along the plateau. And we really now see that the agricultural land has surpassed the amount of shrubland that was before very dominant. And then in the next and final map, we see that agriculture is now really the dominant land cover type, but we also see that the grassland has decreased again and is almost back to its first extent in 1935. We also see that the villages really, compared to 1935, have really expanded together with the agriculture, of course. And we only see like 4 distinctive forests that that are present in the catchment, and they will remain present there because they are there for religious regions, because there are churches there. Now, the same is depicted in these graphs, where you can see the changes in the area of each land cover type for the catchment and for each of the subcatchments, really explaining that there were different evolutions going on in different subcatchments. So in the whole catchment, we see clearly this increase in cropland, mostly at the expense of forest, but also shrubland. But we also see this first increase in grassland over between 1935 and 1967, and then the sudden decrease again between 1994 and 2020. Now, if we look more closely to the first subcatchment, we see that there was already a huge proportion that was used as cropland, but still had a little or a quite big increase between 1935 and 1967, and then the amount of cropland remained quite stable. If we go to subcatchment 2, we see that the cropland has increased quite rapidly, also mostly at the expense of shrubland and the grassland as well. And we see this amount of forest has remained quite stable, also because of the presence of the church in that particular forest. If we look to subcatchment 3, we see here this trend of the grassland first increasing and then decreasing again. This could be maybe explained by the fact that there was a lot of grazing in this period. And we also know that grazing animals are very destructive for woody vegetation, such as shrubland. And then this decrease can then maybe be explained by the fact that in the 1990s, in this area, there have been implemented a lot of land management practices, land conservation practices, which could explain the rehabilitation of shrubland. And of course, also very clear in this graph is the loss of the forest along the escarpment and a small but relatively small increase in agricultural area. Now, what else changed in the catchment? That is, of course, the drainage network and also the riverbank width near the outlet. Let me first talk about the drainage network. So this is, of course, an ephemeral river with a gully network. And we can clearly see this network is most pronounced in subcatchment 3 and subcatchment 1. And there it has also mostly increased. We can say that this has increased with 150% over time between 1935 and 2020. And the riverbank width was studied near the outlet at these points. And there I found that the riverbank width increased from 7.5 meters to 10.5 meters between 1935 and 2020. Now, the next step in the research was to study the impact of these land cover changes on the runoff response in the catchment, and I did that by using the soil water assessment tool, also called SWAT. And SWAT is already globally known and used for studying the impact of land management practices on hydrological, agricultural, and sediment yields. And SWAT does his calculations based on a hydrological response unit that exists out of a soil, slope gradient, and a land cover type. The land cover type I, of course, mapped myself, and then the soil types were also mapped using an extrapolated classification from a soil classification of a nearby catchment in also Ethiopia. And the slope gradient I derived from an SRTM digital elevation model. The idea in SWAT was, if we use constant weather characteristics, constant soil and slope gradient data, and we only change the land cover types over time, then the changes we will observe in the simulation are explained, the changes in runoff response, of course, will only be explained by the changes in land cover. So what you can see now to your right is the different average surface runoff simulated by SWAT for the different subcatchments. And I added again this graph from before because the trends we see here in the surface runoff for each subcatchment is very similar to the changes in the cropland we see or we saw in the different subcatchments. And let me now explain. So we'll start with subcatchment 1, which is here in the middle. It first has a small increase in surface runoff and will then remain quite stable, though it is still increasing. And this is very similar to the trend we saw in here. And the same is, the same counts for subcatchment 2, where we have this very steep or quite steep increase in surface runoff, which is also very similar to this increase of cropland, and also the same for subcatchment 3, of course. Now, what I also did was I studied the relation or the correlation between the increase in riverbank width over time and the simulated surface runoff for the whole catchment. So now this graph represents the total surface runoff for the whole catchment. And I found that there was a very strong correlation between the riverbank width increase and the increase in surface runoff over time in the catchment. Other significant correlations I found in the research was that, for example, the changes in the cropland and the changes in the riverbank width are also very strongly correlated, but also the changes in the riverbank width and the changes in the drainage density are also very highly correlated. And just as an example, I show here how I measured all the riverbank widths for each time period. Now, to conclude, I can say that the landscape in this catchment has really changed over 85 years, and the expansion of the agriculture was a dominant driver, with, of course, a huge loss of natural vegetation such as shrubland and forest land. I can also conclude that the drainage network of the river has expanded a lot, and this has also resulted in a higher drainage density. And this is also reflected in the way that the riverbank width has also increased in time. And then based on the changes in land cover, we can see that SWAT has simulated a higher runoff response over time, which will also result in a higher connectivity of this catchment. And this is all supported by a lot of correlations between the riverbank with the changes in land cover and the drainage network. Now, as a summary, I created a time depth map with which shows you all the changes in land cover over time again, but now more summarized, where the more darker colors show that a certain land cover type occurred at a later time. Thank you for listening.
Thank you, Kiara, for this very beautiful presentation. I see that there are a couple of questions in the chat. I will start with the first one. Did the presenter, I think that's you, consider the role of climate on changing land use, land cover of the area?
Yeah, I'm just going to talk to my screen. In my master dissertation, I did work also with two different climate scenarios to study the interaction, but it was not, let's say, I didn't work with future prediction of climate change. I just worked with two theoretical climates to see the difference, but also the interaction of climate with the whole model, with the changes in land cover type. But I think that doesn't really, it's not the same as in the question.
Okay, perhaps you can stop sharing, then then we can have a more active discussion, and unless you would like to still keep sharing your presentation.
Yeah, no, it's okay.
Yeah, we have another question, and someone is asking if terracing, if the terracing undertaking as a measure, is terracing undertaking as a measure of water conservation and soil conservation in the area?
In the area, I'm not sure if that happened. I can tell you that there are a lot of stone bunds in the area. I wasn't able to visit the area because of the COVID pandemic. So my knowledge is merely based on my observations from Google Earth. So about the terracing, I'm not sure. It is possible, but I'm sure that there are stone buds as a measure of water conservation and soil conservation indeed. But the terracing, I'm not sure. Sorry.
Okay, and then as a last question, is the riverbank width, the active channels, still increasing in the latest periods? So is there no positive effect of land management?
The change in the riverbank width was greatest between 1935 and 1967. Indeed, the change between the last 30 years, let's say, I think it was I think it's only 30 centimeters. So the change in the last period is significantly lower than the first change. So it is possible that the effect of the land management indeed has halted a bit the widening of the riverbank. Yeah. I don't hear you.
And I muted myself, sorry. I was just thanking you for this quick round of questions and answers. But perhaps we can go already to the next presentation by Sofie, Annys, and Nyssen. But I think Nyssen will present here today. It's, of course, on the region of Tigray. Nyssen is the foremost expert at Ghent University of this region, affiliated to the Department of Geography. And their presentation is entitled Mapping the Humanitarian Emergencies in Tigray. So Jan, the floor is yours.
I'm going to present our work on mapping the humanitarian emergencies in Tigray. I'm presenting on behalf of Sofie Annys, who is our main mapper, but who cannot be with us today. And of course, we are in the context of the war in Tigray, and we will explain the map making that we have done. Here you see some of the views of this extreme crisis that is happening, of the civil war that is happening, with bombing of market on top right, and burning of grinding mills, looting of donkeys, and even looting of jerry cans, people who are fleeing to the mountains and simply waiting there until the warfare is over, and food aid that is blockaded along the roads, and starving Tigray, what is happening right now. We have quite some expertise with map making in Ethiopia, but this was about totally different topics. Here you see a map that Sofie made of the Tana Beles irrigation scheme and the development of the Tana Beles irrigation scheme. We also published, I have been working in Tigray since 1994, and we were so naive maybe to work on a geotourism book for the Tigray mountains, and especially Dogatembian, which detailed tracking maps even in it. And in one of our villages where we have tracking routes, we have been busy up to October last year, but these are photos from April, in making footpaths, in making picnic places where the people can sit. If it was not to attract tourists, at least the local people, everybody moves on foot. The local people would move easier through these mountains thanks to these establishments that we were doing. And then the war came. Again, in Togoga, 22 June, there was a bombing of the market where the people were exchanging seeds by the Ethiopian army, and 64 people were killed in that very village. What we did was then, okay, we have our professional knowledge. Can we simply sit and wait until the war is over? I think no, we have to document it. We have to use the power of maps, make the invisible visible. So we collected data from secondary sources. We collected data through interviews, very difficult because most of the lines are cut, but we know our data collectors very well and we work it in trust, and we collected a lot of data. And then we have been using ArcMap and ArcGIS online for doing the technical part of the work. We came with baseline information, also important for NGOs and for international organizations, because the Warreda, the districts in Tigray, they changed in 2020. So there were a lot of new districts, and organizations were mixing the new district names and the old district names and boundaries and so on. So we published a detailed map that gives them very clear delimitation, and everybody is now using these new district delimitations. We mapped the topographic roughness, important if we need to access, if they need to access areas for humanitarian aid, which places are easy to move, which places are difficult. The more reddish, the more difficult terrain. We are in a mountain area up to almost 4,000 meters high. We found a report with a map of the length of the growing period. And you see the darker areas have a longer growing period, the brighter areas have a shorter growing period, and we availed that to everybody. Then we made maps about internal displacement. I talked already about these people who moved from the towns to the villages. There has been huge population displacements, and people, IDPs, it is called, internal displaced persons, living in schools, living in unfinished buildings. We mapped this. We see here on the left map the internal migration. We see that you see the contour of Tigray. You can recognize it now. And Western Tigray has almost been emptied from its population. That means all Tigrayans have either been pushed out to other parts of Tigray, or they have been killed. A small part has gone to Sudan. Small part, 70,000, could escape to Sudan also. In green, the areas that have an increased population, and especially there are some towns like Shire where the population has quintupled due to all the internal refugees that arrived. The same thing is represented on the right-hand map, where the pie charts indicate the size of the IDP population, and the color in the pie chart gives the origin of the displaced people. Then there are the civil casualties, unfortunately, lots of killings, lots of massacres, and we try to get this information from our contacts. It is still very fragmentary information. Even the telephone lines are blocked now to Tigray. But still, we made a heat map of the killings that took place. We have tried to map the massacres. These are even not all massacres that occur, but the rather you can understand the more massacres that are there. The United Nations, they did an investigation about these massacres, but they choose to work with the government-appointed Ethiopian Human Rights Commission, and so they visited only the spots that are indicated with the blue tick marker. So most of the places and the places with the highest amount of killings have not been accessed. These massacres are really extreme. Some of it has been, the soldiers were filming when they were doing. I don't show you you can go to this BBC site and you see how the soldiers really shoot the people on the edge of the cliff and simply joking about them, urinating on them and so on. Even women were participating in the massacre. Even that site was not visited by the human rights investigation. And we created then a spin-off from our atlas. We created a website where all the known information on massacres is collected and compiled. Then there is the problem of famine. Already there was a problem of locusts. Farmlands have been burned, grinding mills have been burned, and there is a blockade, and plowing has been prevented. You see here the accessibility, everything is in red. Well, once you are inside Tigray, you can move relatively easily, but getting there from outside is almost impossible. Bringing food aid in is impossible. No telephone, no internet, no banks, no salaries, etc. The Tigrayans tried to break out, tried somehow to lift that blockade. They tried to move with their army in southern direction. For the moment, they have been, or they have been pushed back. So for the moment, it remains a total blockade of the Tigray region. The cropping season has long started. The long cropping season is by the end. The problem is that the cropping season started in June, and that was when the army was still there. And the army was actively preventing plowing. Even along the Tekeze River, where we had done earlier studies about the irrigation, we could see that all the areas in red color, the irrigation did not take place, thanks to satellite imagery, of course, and knowing the area. The places with green color had been irrigated and some crops were grown. And then we did interviews in the field. Our colleagues from Maale University went to the field to collect data. And if you see the left graph, you see a normal situation where most of the land was sown in one district with wheat and barley. And in 2021, relatively small area was sown with wheat and barley, mainly because the people, they have eaten their grains. Yeah, they were hiding in the mountains. They took their grain with them. They roasted it and they had to eat it. And you see in brown color, you see a strong increase of fallow area. Normally, there is no more fallow because there is a high population density. But many lands were left fallow because people moved out. So people were then doing this indigenous seed supply. They were exchanging seeds, and they have increased the amount of teff. And teff is a seed that is sown late in the season. So after the soldiers moved out, they could still, you see here a farmer who is still trying to plow on. The weeds are emerging strongly, but he's still trying to plow, and he has sown his land. So there is this, farmers have been working hard to try to get their crop, but there will only be between 25 or 50% of a normal crop yield. And here I'm taking some maps from the famine early warning systems network, where you see Tigray in the northern part of Ethiopia, totally in green, which is a minimal food insecurity. And you see the situation in September 21, and it has even worsened now with most of Tigray in emergency and famine conditions. The estimation is that between 400 and 1,200 people are starving to death daily. And how long is this still going to go on? We continue mapping, but there are, of course, we are now counting deaths in hundreds of thousands. Now, the outlook for our atlas, we will bring in some additional documents. We'll bring in some new maps. We found a unique map of the pre-colonial period, 1850, where we see Tigray in yellow color, and then the Amhara region in blue color. It can overlay the current situation in blue, the Red Sea and the main rivers. And then you see the red lines that represent the outline of Eritrea, because there has been colonization, of course. There was also a strong push after 1850 by Emperor Menelik to the south. And sometimes he has been compared like the Ethiopian counterpart of Leopold II. They had the same exploitation system, which is at the base now of all these civil wars that have occurred in Ethiopia. Another map that we are preparing is a map of the gold exploration licenses. Everything that is in brown are licenses that are given to Canada, and that would probably explain why Canada is so silent about the war in Tigray. They have huge economic interests together with the Ethiopian government. So as a conclusion, we have all these conflict incidents. It continues to occur on a daily basis. We have identified 9,300 civilian casualties, of which more than 3,200 have been fully documented. About 1.7 million people have been internally displaced. Many other war crimes and crimes against humanity, I could talk about gender-based violence, have been committed. This is the largest famine worldwide since 10 years, with humanitarian aid access that is totally blockaded. So we are in a very dire situation. Thank you for listening to me. And if you go to this website, ethiopiatigraywar.com, you get the details on the massacres and the civil victims, and you can also download our atlas. Thank you.
Thank you so much for this presentation, Jan. I see there is a lot going on in the chat. I will not go, yeah, you can stop sharing your screen if you would like to, because we see now, okay. Yeah, okay. Of course, I will not go into depth on the political situation, but just perhaps to summarize a bit of the question, I can imagine that in this context, it's sometimes difficult to verify your sources. How do you tackle this issue?
Yeah, this is, well, on one hand, we are getting the secondary data, and they come very often mostly from sources within the UN system. These people have to be very diplomat. If they publish it themselves, they may get, and people have been expelled by the Ethiopian government. So we are getting from some parts of the UN system, they are giving our data and they are trusting it for publishing it. When it comes to the massacres, this is a very painful investigation, because in the beginning, people didn't want to share this information. Because in the Ethiopian tradition, in the Ethiopian culture, or in the Tigray culture, you don't inform about somebody who dies. First, all the relatives needs to be informed. And only then after that it can be made public, because otherwise people should be confronted to a bad situation. And it took some months before people started really sharing that information broadly. When we got this information, we have a big network. We have been working there since '94. And each time when telephone lines are reconnected, we telephoned to those districts to ask people, did you hear about the massacre in that village? Oh, yes. Or we have had two cases only, where we got the feedback that no, there has not been a massacre. People were trying to get food aid or something, and they invented a massacre for that purpose. That was 2 cases out of the 250 massacres. What else is that very often when international media can go to those places, they confirm it. We were speaking about the Aksum massacre, and then 2 months later, the international media were also confirming it. So I think that's another way of verification. And so far, nobody has ever disproved any of the massacres that is in our list.
Okay, thank you so much. I was discussing with the technical team about the next speaker. Sorry for that. I see there is some contestation, of course, in the chat. I will not go too much into depth into that, also because of the time limits. So if it's okay for you, I would like to go to the next speaker now.
Obvious, and you have seen the website, and you can verify everything. Thank you. Have a good day.
Jan, for this nice presentation. We will stay a little bit more in Ethiopia with the next presentation by Emnet Negash from the Institute of Climate and Society at Makerere University. And his presentation is entitled Diurnal Cycle of Submarine in the Ethiopian Mountains using Climatological Model Data. So Emnet, the floor is yours.
I'm here to talk a little bit about the diurnal cycle of summer rain over the Ethiopian highlands, Ethiopian mountains generally. And the work is basically based on climatological model data. And I start again by introducing you with why is this study relevant? So looking into the Ethiopia's topography, we have the highlands with temperate-like climate and desert-like conditions in the lowlands. And these highlands are basically of highly densely populated areas, and agriculture and mainly crop production happens to be the dominant economic activity in these highlands. And we have diversified climatic zones based on the Köppen classification again. And if you see this 4 of these maps, they happen to be interrelated to one another. And so it seems that the agriculture and the crop production is highly affected by the other factors, the climate and the topography again. So the topography happens to be an important factor. And so a little bit more about the Ethiopia's agriculture and its susceptibility to climate variability. So then the Ethiopian highlands are home to more than 90% of the Ethiopian population, and which constitutes about 90% of the total area suitable for agriculture. And so the livelihood of about 66% of the Ethiopia's population depends on subsistence agriculture. And so with this, a little or small variability in rainfall can cause massive economic loss for farmers reliant on rainfed agriculture. And so accurate understanding of the top climatic effects on rainfall distribution, among many other factors, would therefore are crucial to enhance sustainable development in countries like Ethiopia and in the tropics in general. But then due to lack of detailed scientific knowledge, a one-size-fits-all agroecosystem management approach has so far been used in Ethiopia and elsewhere without considering the rainfall variability, which we think is important and for which we think to look into. But the challenge, however, is not only in Ethiopia, but also throughout Africa, I would say. We have lack of data. The reference data is missing. For instance, if we look into the gauging station networks in the world, and of course, if we look into Ethiopia, we have a very sparse network of gauging stations, which again would come with large representativity error. And the other option we have, of course, is the satellite rainfall products with a short period of availability to study the climate. And we again have the poor spatio-temporal distribution to look into the climatic effects, which seems to be a challenge. And so our interest now is the orographic rainfall, where we have the adiabatic lifting of the prevailing winds coming on the windward side, and which raise up and expands until it cools down, until it reaches a saturation point and water falls in the form of rainfall. Whereas if we could go to the other side of the mountain, then we mostly have the rain shadow effect on the leeward side. So then this mechanism is quite known to exist in the mid-latitudes with persistent pattern of air circulation. But then the question is, how can we investigate these orographically complex regions like in Ethiopia or other parts of the tropical Africa, where we have variable air patterns and again where we have convective rainfall is again important. So what options do we have? Among the options we have for regional climate simulations are that we have the Cordex Africa, which includes regional climate model runs over Africa, showing wide range of model runs. But then the uncertainty on the model is much larger than the observational uncertainty, as you can see on the plot on the left. And so the other more important challenge is, however, they have a spatial resolution, a horizontal resolution of up to 50 kilometers course, which does not enable us to detect, to look into the topoclimatic impacts. So what other options do we have? Again, we have the Alaro model, the Alaro climate simulation, which we have at the RMI Institute here in Belgium, which considers the time between 1990 to 2010 followed by a reanalysis with horizontal resolution of 4 kilometers and covering the main rainy season, which is quite important. And the validation seems to show that this model is a bit represents the topography better than other models we have so far. So looking into the altitude, the wind and rainfall categories, let's start from the proportional distribution of elevation. So the proportional area of elevation categories continues to decline with increasing elevation. And most of the area happen to be in the low and over the lowlands. And with increasing elevation, we have diminishing size. And if we look into the wind categories, the category frequency of winds, and so we have about 5 wind categories. And so the lowland areas are dominated by flat category, while with increasing elevation, we have the increasing occurrence of the windward and leeward events. On the other hand, we have the top and valley events, which are altogether contributing less than 5%, which seems to be quite negligible. And if we also look into, on the right side, we have the category frequency of dry and wet categories, dry and wet rain categories. So the lowland areas are mainly attributed to dry conditions, while with increasing elevation, the occurrence of wet conditions also prevails with increasing elevation. The plots here are showing, again, confirming that the occurrence of flat categories is in the lowland areas, while with increasing elevation, the occurrence of windward and leeward categories also comes. And the plots here again shows the diurnal cycle of rainfall, both the precipitation frequency as well as the precipitation amount, which is the intensity. On the x-axis, we have the hours of the day, while on the y-axis, we have the elevation categories. And so the orographic convection in the morning hours enhance the rain in the noon and afternoon hours, especially at higher elevations. And hours of the day between 10 and 15 for experience maximum precipitation, which is the noon hours, both for the frequency as well as the amount, unlike the night and morning hours. So looking at the rainfall difference, the positive rainfall difference between the windward and leeward, both rainfall probability as well as the intensity are generally higher on the windward side. During the noon hours, the peak hours, however, the leeward sides experience higher rainfall over a shorter window time. And it's not only the rainfall that we are looking into, but we are also looking into the diurnal cycle of temperature, humidity, wind speed, as well as the rainfall. So looking at the surface air temperature, then the increase of temperature and humidity starts hours ahead of the wind speed as well as the rainfall's diurnal cycle. And so the temperature mainly drops in the afternoon hours due to the reduced incoming solar radiation, which also has to do with the cloud cover we have coming with the coming of the rainy hours. And so the surface humidity also increased in the morning, while it decreased in the afternoon due to atmospheric mixing, the mixing of this latent heat throughout the atmospheric layers. And looking at the wind speed, for instance, on the other hand, so we have the clear diurnal cycle during the day, especially along the windward, while we have the weak diurnal cycle for the leeward. Although there are relatively no winds during the afternoon, during the evening and night hours, especially, so we still have increased rainfall. The rainfall continues to fall during these night hours, especially in the windward sides. So then, what are the mechanisms again? So like we said, we have the mechanical forcings and as well as the thermal forcing. By the mechanical forcing, we are referring to the prevailing winds, mostly in case of Ethiopia, coming southwesterly winds coming and from windward side, and while we have the rain shadow effect on the leeward side. But it's not only factor we have in Ethiopia. So like we said, like the prior graphs showed us, there is a higher precipitation, rainfall, wind speed, as well as humidity during the noon hours. So there is this diurnal cycle, which always has to do with the incoming solar radiation, which is again to do with the temperature. So there is that thermal effect with increasing temperature. Then if we consider, for instance, there is no much large-scale wind pattern, then with the latent heat would rise possibly from any side of the mountain in a convergent flow. And so, but it's not the only factor again. We always have these two factors, the thermal as well as the mechanical forcings, working all together in Ethiopia and in other tropical mountains in Africa also, which is again complex to understand, and we are trying to look into. And so, in conclusion again, so what we can say from what we have seen so far is that there is generally more rainfall mainly during the noon and afternoon hours, especially at higher elevation, and that the predominant afternoon maximum rainfall as well as the prevalence of windward over leeward events and high orographic rainfall suggest terrain-induced accent owing to thermal rather than mainly of wind-induced forcings. And therefore, since this is likely to affect the farming systems in general and among, of course, many other sectors as well, this study is highlighting the need for an alternative approach replacing the one-size-fits-all agroecosystem management approach with a site-specific one, considering the topoclimatic difference as well. Thank you.
Thank you so much, Emnet, and I'm so happy for you that it worked out well in the end. Yeah, there was one question in the chat, I think, but it was more technical question regarding slide 8, what is on the scale bars. So that was more an informative question.
Slide 8, if I can go to slide 8, may I share it again so that we can?
Yeah, perhaps you can share it again.
I guess it would be this graph.
Yeah, I think it's this one, yeah.
Yes, if I may share it full screen again. So we have on the x-axis, we have hours of the day, starting from the noon, like the 00 in the midnight, in the night hour, up to from 0 to 24 hours, ranging. So from 0 to 24, back to 0 again. And on the y-axis, we have the elevation categories. So here, for instance, in this particular graph, we are looking into the diurnal cycle of rainfall on the Windward throughout the day. So in the morning hours, in the night hours, early from 00 up to 6 about, for instance, we are having limited rainfall, whereas in the noon hour, close to the noon hour, starting at 9, 10, 11, 12, up to 14 hour, we are having higher rainfall. And again, back to the evening hours, the rainfall drops back. And it's not all over, but at higher elevation, lower elevation are again having limited or no rainfall again. So we are looking into the diurnal cycle. On the x-axis, we have hours of the day, and on the y-axis, we have the elevation categories. And so we are looking into the diurnal cycle of the rainfall, the frequency, and again, the amount we are looking into. And on the third one here we have is the relative difference between the windward and leeward. So the red color would mean positive difference, which means windward sides are having higher precipitation frequency and amount in this case in throughout the day. But along this particular peak hours, we are having the inverse relationship. I think that's what I can say for now.
Okay, thank you so much, Emnet. I see a lot of appreciation for your work in the chat, so thank you. And then I would like to go to the next presenter.
Thank you.
Who is Anthony Denayer. Anthony, I think you have arrived now in the prayer room. If so, you can go on stage. Are you there? Yes, I see that Anthony Denayer from Vétérinaires Sans Frontières in Belgium is present. And if you would like to, you can start sharing your screen for your presentation on ecosystem disruption and zoonosis. So the floor is yours, Anthony.
Okay, thanks a lot. Can you all see the presentation right now?
Perfect, in full presentation mode.
Okay. Yes, good afternoon, everyone. Thanks for having me. So I'm an operational communication officer for Vétérinaires Sans Frontières, or Veterinarians Without Borders Belgium. So unlike most of you, I'm not a researcher, but work for an NGO who is trying to collaborate as much as possible with research institutes to enforce our communication. Now we're talking about ecosystem disruption and the link to zoonotic disease emergence today. So just a word about VSF, Vétérinaires Sans Frontières. We are a development organization who recently also started up again our humanitarian aid interventions, since there's quite some insecurity and instability in the regions where we work. And just to give you a bit of a picture where we work, so we're active in Africa only. So the darker colored countries are where we work with the Belgian affiliation of VSF in 9 countries with about 33 projects ongoing right now. So today, as I said, I will talk about the link between zoonotic disease emergence and ecosystem disruption, and then link up to how we are actually helping to prevent zoonotic disease outbreaks and consequent pandemics or pandemic risk. And as to finish my presentation, just a call for collaboration with researchers that might be applicable or relevant to our field of expertise. So to start with, zoonoses, as probably the whole world knows now, are diseases that are transmitted from animals to humans. They comprise of 60% of all infectious human diseases, and about 75% of all these are actually emerging novel diseases, infectious diseases, and novel zoonotic diseases. Another interesting fact is that 100% of the pandemics are actually caused by zoonoses. And needless to say, these novel disease emergencies that lead to pandemics cause quite a serious threat to public health and society as a whole, as we have learned from this recent COVID-19 pandemic. Now, another fact is that this rate of novel disease emergence or zoonotic disease emergence is accelerating today. So on this graph, you see the cumulative number of viruses or virus species that affect us as humans. And we see that over the past decades, we are confronted with about at least one new infectious disease every year. But if you would look at the geographical spread of these novel infectious diseases, yeah, you would see that it's really exponentially spreading and accelerating the rate of these emergence of infectious diseases. So this study kind of summarized the way these diseases spill over from animals to humans. And here I want to draw your attention to the box in the middle where it says 71.8% of the emerging infectious diseases originate in wildlife. So if you follow the blue, yellow, and red lines, that is these are illustrating wildlife species that are at the origin of infectious diseases. So all these new infectious diseases that pose a threat to us and have pandemic risks, bring along pandemic risks, 71% originate in wildlife. And how does that come? Well, obviously, more than ever, it has become clear that this is closely related to our human activities, that the same activities that cause biodiversity loss are the ones responsible for this increased rate in novel disease emergence. So deforestation for human development, for agricultural expansion or urbanization is causing ecosystem disruption and is disturbing the habitats of many mammalian species. So such as you can see on the drawing here. So most of the reservoir hosts of these novel diseases are apes, primates, rodents, and bats. So by causing stress to these habitats, we see that these reservoir hosts, these bats, for example, their resistance can quite reduce and they can become themselves more susceptible to the virus, which increases the amplification of the virus in the reservoir host, and it therefore also increases the viral shedding. So they actually produce more viruses infecting each other and then increasing the risk of spillover to other animal species or humans as well. And as this study has shown, if you look at the right graph, which shows the cumulative zoonotic emerging infectious disease events, you can see that almost half of them are identified to have been caused by agriculture and land use changes. So agricultural industry, food industry, and land use changes are the underlying factors for these zoonotic events. so I find this diagram quite summarizes it quite well. And here I'd like to draw your attention on the highest peak, where it says the domestic animal amplification. So yeah, this causes quite a serious threat to this disease spread, since our industrial livestock systems tend to keep our livestock in quite close among each other in quite closed environments. So this amplification of viruses within our domestic animals is quite rapid, since the very low genetic diversity also within our production systems. And we can say the same about humans, mainly in the West, where we also live quite close to each other in closed environments. So we have seen with the COVID-19 pandemic that that can lead to quite some fast spread. So the underlying factors of the accelerating rate in zoonotic emergence are definitely our human behavior, and mainly these activities listed here. So deforestation, our intensive livestock production, antimicrobial resistance because of the improper use of antibiotics, the illegal and poorly regulated wildlife trade, and climate change. And maybe a little more about climate change. So many diseases, as you have seen in the previous graphs, they are carried or transmitted by vectors such as mites, mosquitoes, and ticks. So climate change is really causing these vectors to be able to spread into new geographical areas, but also their life cycle is increased. And other factors related to climate change are that, for example, due to droughts or floods, many farmers have poorer harvests because of climate variability, and this causes them in certain areas to go into natural areas to hunt for bushmeat, for example, bringing them again in closer interaction with wildlife. But on the other hand, we also see that, for example, the fruit bats, which are an important reservoir host for many of these diseases, they go and look for alternative feeding places in a dry year, for example, when the fruits in the natural areas are not available anymore. They tend to go to where humans are growing these fruits. So it all increases the interaction between animals and wildlife and increasing the risk of spillover. So in the end, yeah, it's just our entire economic system, in our global food system, that is the underlying factor where we are really overshooting our ecological ceiling whilst not being able to meet the social needs of all humans worldwide. But so what do we now do to control zoonotic diseases, outbreaks, and to prevent pandemics? Well, obviously, our core business is animal healthcare. So we deploy quite a lot of vaccination campaigns. We strengthen veterinarian networks and raise a lot of awareness about zoonotic diseases among farmers, the local population, and so on. But as you can see here, this might remind you a bit of the flattening the curve graph of COVID. So basically, preventative animal health surveillance, being on the field, detecting early certain outbreaks, and then applying the right control measures is how we control diseases and prevent these outbreaks. Like recently, we had to quarantine quite a good number of livestock in Uganda because of a foot and mouth disease outbreak, and obviously this has quite some benefits to animal health and human health in the end as well. But to reach the last mile, this is really our focus or one of our best practices. We invest quite a lot in the support of community animal health workers. So these are better livestock keepers elected by the community that get support from private veterinary doctors or veterinary public services and us as well. We provide trainings so that they can provide the basic animal health care services and advice to livestock keepers. But for most, these guys, they play really an important role in the epidemiological surveillance. But as we've seen from the underlying factors, it's about more than just animal health care. So we really need to focus on agroecological livestock production systems that are able to produce sustainably in harmony with nature. So that's why we have quite some projects where we focus on sustainable grazing management, grassland, land tenure security, grassland rehabilitation, and so on. So this is, for example, a picture I took in Tanzania, where you can clearly see that this was detailed planned grazing, because when I would turn my camera to the left or the right, I would see only maybe a few wildlife species, but no livestock. And here, if you look in the back, you can see quite a number of herds traveling or grazing specifically here, and then moving onwards and leaving the other areas to the wildlife, and balancing their grazing pressure correctly, not over, not under grazing, is keeping this ecosystem healthy, as these grasslands evolved in history in harmony with also wild grazers. They're really like managing or conserving the ecosystem. So a picture on the same day where you see in the foreground 4 antelopes running away. This guy was still moving towards the area where he was supposed to graze, where the community had decided to graze. On the same day, we saw some giraffes, some lions as well. Just to show you that, this is quite an extraordinary livestock production system in harmony with nature. So with VSF, we protect their land rights. We help them drawing land use plans, and with these land use maps, along with some bylaws, they were able, or we were able to help them to get certificates of customary right of occupancy. So nowadays they have their land rights are protected on the name of the community forever. So there was no end date to their land rights. So and just as an example, in Tanzania, we did this for about 96,000 pastoralist households, and for about for over 700,000 hectares of land that are now secured. And it's not only about conserving the biodiversity and the ecosystem, but even now a lot of research is showing that actually grasslands are storing quite a considerable amount of carbon in their soils. And this nature study found even that grasslands actually store more carbon in the soil than forests, so below ground. And they were really urging that these projections of soil organic carbon might need to be revised, because they play quite an important role in our climate mitigation efforts to store carbon. So as grasslands can serve as quite an important nature-based sink. So all we need to prevent is this, and that's what we try to do with protecting land rights, trying to keep the carbon in the soil, protecting the ecosystem and the biodiversity, and in that way also preventing zoonotic disease emergence. So how to prevent the next pandemic? Well, basically, it's not only about animal health care, but also about these ecosystem management activities that we do. And altogether, we call this the One Health approach. So that's what we really stand for, promoting or actually recognizing the intrinsic linkages between the health of humans, environment, and animals. And this requires some a multidisciplinary, holistic approach and quite some collaboration. So we do collaborate with a lot of public health organizations, such as the Red Cross, such as Doctors of the World and Caritas International, but also with environmental organizations such as WWF and the IUCN. But now, our activities are also based on research. We try, and as well as in our communication, we try to do to communicate in an evidence-based way and to do scientific communication. So that's why we really always look for research collaborations. And I have just a few examples of previous research collaborations. So we welcome quite a lot of master thesis students, such as in Uganda. We had a research on tick-borne diseases and the pastoralist perceptions with Ghent University. Today ongoing, we do more than, we also work in Rwanda with biogas digesters. So we have the research ongoing now on the greenhouse gas effect of installing these biogas installations instead of using charcoal or firewood for cooking. They use biogas that is produced by cow manure. And another ongoing research also with the KU Leuven is on the production of larvae of black soldier fly as a quality protein source for chicken and pig feed. So it's a kind of a circular economy project where these larvae can convert food waste into high quality proteins for animal feed. So that's it, and thank you for your attention, and you're all welcome to contact me if you have some interesting research in mind in the countries where we are active with any topic related to livestock production or animal health.
Thank you, Anthony, for your very interesting and fascinating presentation. It's very impressive, the work you're doing. Also, the presentation, I have to say, I found it visually very strong. So thank you for this. I think a lot of people reacted very positively in the chat, and we also got some questions. So the first one is, are you integrating phytotherapy or naturopathy, sorry, I don't know this term, into your preventive and curative means?
Can you repeat again, because you're disrupting a little bit, the internet connection is a bit
was
unstable.
there an interruption? Sorry. So the question is, are you integrating phytotherapy or naturopathy, I don't know what it means, I have to say, into your preventive and curative means? That was the question, the first one.
Yeah, first of all, I'm also not a veterinarian. I'm an agriculture engineer, so I'm not really familiar with the terms. But if it's like about medicinal approaches, if I might be correct, I don't know, then yeah, we do consider some of these medicinal and traditional plants and methods to keep animals healthy.
There is also, yeah, so the person is providing some more information. It means using plants to preventive and cure both human and animal diseases, indeed. Yeah.
Yeah.
Then there is
that is quite known indeed. But as I said, I'm not an expert, but I do know from my colleagues that they are quite aware of these plants and so on. So basically, we do not have to promote it that much because the local communities are mostly better aware than us about it. But yeah, some of them are scientifically proven to work, and others are not. But yeah.
And then there is a more informative question. How does the GHG biogas digester function? So that's for some words of explanation are asked.
Yeah, so these biodigesters, they work with manure of 2 cows. So any family in Rwanda who has 2 cows can apply for a biogas digester. So yeah, it basically works by the production of methane when the manure is in the dome, and then the methane is there's a pipe from the top of the dome that goes to the kitchen, and yeah, then they can cook with that biogas. So the major constraints are usually to get continuous input and enough water, because in the dry season sometimes the biodigester stops functioning because of lack of water. So that's why we're also installing rainwater harvesting tanks to keep the biodigester going on. And then also at the effluent, the remaining part after the fermentation process, that we can use as a biofertilizer. So that's applied on the land as a fertilizer.
Thank you so much. I think we have to go to the last presentation, and keep in mind Anthony's request for more collaboration, so you can always contact him. So the last presentation will be by Gijs de Kort and Dirk Verschuren. I hope you have now arrived in the prayer room. It also means, of course, that we don't have Obeson today in this prayer room. He probably wasn't able to connect. But if Gijs or Dirk are there, I would like to invite you to come on stage. Dirk is there.
Yes. No,
so happy to see you. So you will do the presentation?
Yes, I will.
So then you can perhaps share your screen for your presentation entitled A Long-Term Hydroclimatic History of the Eastern Lake Victoria Region.
Okay. Well, sorry for the slow start. Well, yes, so I'm presenting the work by a group, primarily here at Ghent University, but also collaborating with the University of Nairobi in Kenya, and also CNRS in France, on paleoclimate reconstruction for the Eastern Lake Victoria region. Let's start with, let's say, a general setting, a climatological setting. Probably most people know that the seasonality of modern-day rainfall over East Africa is mostly determined by the north-south migration of the intertropical convergence zone over the continent, and also a little bit the interaction between western moisture sources coming from the Atlantic versus eastern moisture sources coming from the Indian Ocean. And this has the result that over a lot of northern Africa, there is a single rain season, typically during the northern hemisphere summer months, and that over intertropical Africa, yes, there are 2 rain seasons, between one in March through May and the second one in October, November, respectively, the long rains and the short rains. Now, of course, this climate system has always existed, yes, but in the early Holocene, that's the period between about 11,000 and 6,000 years ago, generally over much of Africa, rainfall was substantially higher than today because of increased solar insolation over northern Africa during northern hemisphere summer. And you can see this here on the right. These are a number of paleo rainfall indicators extracted from lake sediments, and that basically show that indeed in this blue area, the period between about 11,000 years ago and 6,000 years ago, the rainfall was higher than today. And supposedly that was also the case in Lake Victoria region. Now, the question is indeed, is this in fact also the case for the generally drier portions of East Africa, yes, that have a negative water balance, where annual evaporation is substantially higher than annual precipitation. And as a result, lakes can only exist because they are collecting water from a large catchment area through rivers, collecting all rainwater in the lakes. And a good example of that, of course, is Lake Victoria itself. And particularly, yes, if rainfall was indeed higher during that time, was it also the case that the overall moisture balance, so the ratio between precipitation and evaporation, was also higher? And so we decided Lake Victoria itself, of course, has lots of sediments deposited on its bottom, but because it's a hydrologically open system, with an outflow on the Victoria Nile to the north towards Lake Albert and then towards the Mediterranean, it is not very sensitive, hydrologically sensitive to climate change, and therefore not a good climate change recorder. However, there is a small crater lake near Nyanza Gulf in the eastern portion of Lake Victoria Basin. It's a small crater lake, a saline crater lake, Lake Simbi, yes, which is in a hydrologically closed basin, and as a result, we can trust it to be a more trustworthy recorder of past climate change. And so we went there and collected sediment core from the bottom of this lake. It's a salty lake. It's about 25 meters deep at this time. And what you see here on the left is basically the age depth model of the sediment sequence that we recovered from this lake. Basically, it is a column of mud going down 8.3 meters almost, and which also covers around 8,300 years of basically climate history in that region. Now, what will strike you immediately is that the relationship between sediment depth and age is not nicely linear, but really makes these big jumps, yes, across these red and orange horizons in the mud. And these are layers that are composed of pure sodium carbonate salt crystals. And particularly interesting are these orange zones here, because this is the mineral nacrolite, yes, which is actually quite rare in modern day environments. It's only found in a small lake to the north of Lake Magadi. But obviously, yeah, in these old deposits, you can find it more frequently, and of course it reflects very, let's say, dry conditions when the salts in the water are being concentrated because of strong evaporation until the crystals precipitate. The red zones here represent trona. Yeah, that is the salt mineral that is famous from Lake Magadi, also Lake Bogoria, and so on. The gray portions in between, this is the real lake mud that we can then analyze. But it's clear that the salt deposits were deposited in a relatively short period of time, just a couple of decades or just a couple of 100 years. So what we did is we analyzed the mud in between those salt layers using X-ray fluorescence. And that is basically a non-destructive scanning technique that reveals the elemental composition of the minerals in the mud. And of course, those minerals are, for example, potassium, calcium, titanium, manganese, iron, strontium, zirconium, and then also here sort of like a composite index. Now, what is interesting is that four important mineral elements, with namely manganese, iron, titanium, and potassium, yeah, they tend to covary through time in the sediment record, yes, and therefore create a distinct signature in a multivariate analysis of all of our samples, yes. On the right, you can see indeed all of these individual samples, which are colored with the older samples, starting around 8,000 years ago in light yellow, and then coming towards the present becoming orange, red, and purple for the recent sediments. Yes. Now, besides doing this geochemical analysis on the long core, we did the same also on a number of short cores, yes, that were taken in a transect from the central portion of the lake, which is deep, to the marginal portions of the lake, which are more shallow, yes. And it turns out that shallow water sediments, yes, in this short core from around 10 meters deep, have a signature, yes, that also corresponds more with these yellow symbols here, yes, and therefore, yeah, are more similar to the mud that was deposited early in the history of the lake, around 8,000 years ago. Whereas indeed, of course, the modern sediments at the coring sites, yes, are of course reflecting deep water sediments, and therefore corresponds, of course, with the more recent samples. So the point is that indeed this geochemical composition of the sediment can therefore be used as an indicator of past changes in water depth. And this is what we have here. So this is basically the PCA1 score, yes, of the XRF elemental composition of the sediment, yes, and how it changes through time from 8,300 years ago, coming towards the present, yes, bridging, of course, those massive salt layers where we cannot do this kind of analysis. And what you basically see is that from around 8,000 years ago towards the present, obviously there has been quite a bit of variability, yes, in the depth of the lake, and as therefore also the climatic moisture balance. But there is a general trend, yes, where it looks like, yes, the early or mid-Holocene period between 8,000 and 5,000 years ago, and also up to 4,000 years ago, was generally drier, and coming towards the present, it looks like it's generally a deeper lake, and therefore implied a wetter climate. And so basically here, what you see here in the center of this plot, yeah, is our high resolution reconstruction of how climatic moisture balance in the Eastern Lake Victoria basin has varied from 8,000 years ago towards the present. And what you can clearly see indeed is that in the middle Holocene, yes, it was quite dry, and in the last 4,000 years, it has become wetter. And that is, of course, opposite to what everybody would think based on actual rainfall proxies, rainfall indicators, suggesting that the early Holocene was wetter than today and mid-Holocene, and it's only in the late Holocene that it's actually becoming drier. Now, how can this contrast or conflict be explained? Well, rainfall is not the entire story, yes? What also needs to be known, what you also need to look at, is the impact on variation, past variation in temperature on evaporation, because that eventually will determine how much of the rainfall will remain available in the landscape, yeah, for as water resource. And in this top plot, you can see a reconstruction of paleo-temperature variation in East Africa based on other studies, showing clearly that in the middle Holocene, the period between 8,000 and 4,000 years ago, it was warmer than today, yes. And so our theory or our explanation is that it is because it was, at that time it was warmer than today, there was more evaporation, and so notwithstanding the higher rainfall, yes, it still resulted in lower lake level, or otherwise lower moisture balance, less moisture available. And so taking into account both the changes in temperature and rainfall, the truth of the matter is that climate in East Africa has actually become wetter over the last 4,000 years, not drier, as you would be implied from rainfall alone. And so what is the main message, of course, is that if you're also trying to predict future climate change, yes, because of changes in greenhouse gas concentrations, it is not so important to try to predict changes in future rainfall. What you really want to know is changes in overall moisture balance, because this is what will determine overall moisture availability and water resource availability. Thank you.
Thank you so much, Dirk, also for sticking to time, because we are already a little bit over time. Thank you for your very beautiful presentation, also with a lot of co-authors. I'm happy to see them also here on the slide. I don't see questions in the chat, so I think we will close this session here. Thank you for all the paper presentations, and I hope you all really enjoyed this session.